Hi, this is Mr. Kidd, and today I'm going to show you an example of how to use base 10 shorthand to help you do a subtraction problem up to 4-digit numbers, and to make sure that we are recording what is happening on the base 10 board. So here we have the base 10 shorthand board. The amount that we're working with today is 3,142. So if I were going to show 3,142 on my base 10 shorthand board, I would draw 3,000 100, 4 tens, which is 40, and 2 ones. Now, since this is a subtraction problem, we don't want to put more on the board. We're going to take the amount off the board that we're subtracting. And in our example, we are subtracting from 3,142. We are subtracting 1,354. If I am using the standard algorithm, we must first make sure that we have our numbers organized by place value. And as you see, we have our ones with our ones, our tens with our tens, and our thousands with our thousands. This is very important. We want to add and subtract with the same place value. So, we're going to start with our ones. As we look, we are trying to take 4 ones from 2 ones. And as you see on our board, we only have 2. We do not have enough to take those 4 ones from those 2 ones. So the ones must get help. The ones may go next door to the tens and may get one of the tens. Now, when that 10 is brought to the ones, it no longer stays as a 10, but now it's split up into 10 ones. So if we take 110 to bring to the ones, we now have not 4 tens, but now we only have 3 tens, because now this 10 is now represented in the ones place. So now we only have 3 tens, but now instead of only having two ones, we now have 10 more ones, which makes 12 ones. Now we are able to do the subtraction. If we take 4 ones away from the 12 ones, we will end up with 8 ones. Now that we're through with the ones, we'll now go to the tens. Right now I have 3 tens that are there, but I'm trying to take 5 tens. Of course, there's not enough tens. So again, the tens can get help from the hundreds. If they go get that 100 and bring to the tens, that 100 is worth 10 tens. Because 10 times 10 is 100. So now the way we record with our numbers, what's happening with our pieces, is that we no longer have this 100 in the hundreds place. So now we have no hundreds, but now we have, instead of just three tens, we have 10 more, or we have 13 tens. So now we are able to take off the 5 tens, and that leaves us with 8 tens. As we move to the hundreds place, we have no hundreds there now, but we have to take 3 hundreds away. Before we can take 3 hundreds, we need some hundreds, and we can get hundreds from the thousands place by taking that 1,000, and that 1,000 divided into hundreds is equal to 10 flats. And each flat is 100, so 10 hundredths is 1,000. We no longer have that 1,000 there, so we only have 2 thousands left. But now instead of having no hundreds, we have 10. Now we're able to take the 3 hundredths and of course that leaves us with 700. In the thousands place, we have 2 thousands, and we're trying to take 1, which we can do, which leaves us 1,000. So our difference, or our answer to this problem, is 1,788. If you have any more questions, you know how to contact me through my email or through my text. Have a great day.